So good afternoon, everyone. Welcome to another lecture on advanced topics in networking. The topic that we are going to discuss today is network management and operations. So for the last few weeks, we discussed a few different topics around cloud computing, cloud networking, security around those. But when we think about enterprise networks, one of the critical components of maintaining and keeping up enterprise networks is ensuring their reliability, security aspects, and performance of it. And all of those things can be sort of grouped together as this domain of network management and network operations. So today we will go through some of the key areas relevant to this. We will look at some of the industry best practices and stuff. Again, we will not go into a lot more detail into any sort of practical elements of how you would do this, but rather what are some of the things that are necessary to do. Because a lot of the practical elements would be more specific to the context that you are working on. Tools and techniques may change depending on the type of network, type of tools and hardware and a ecosystem that the network uses. But we will cover some of the more fundamental concepts, and then those can be translated into any practical context. So when we say network management to start with, it's about the administration and maintenance of the networks, essentially. To think of like what are the different tasks that would be involved in this, this is where we would start with sort of performance monitoring, so seeing how things are going in the network. Managing configuration, so this is where we set up things, make changes to the setups, configurations, and all that. Security becomes an important part again. Some of the things that we discussed last week as well. So how do we secure the network that we have in terms of who can get in, who can get into which part of the network, and so on. And one of the most important ones would be when this would become critical is when things go wrong, and that is handling faults. So a network that's working fine, if everything is set up correctly, things would go fine and nobody thinks about network management or operations or anything like that. But when things go wrong, that's when people start to think about these things. So that's why it's important to have a lot of these things prepared, understood in advance, rather than trying to figure out when things go wrong, because things will eventually go wrong in any environment. So essentially, when we think about network operations, it's more about the day-to-day running of these things. Instead of just thinking about the overall, what are the right things to do, but network operations is like day-to-day fixing things, setting up things, removing things, and all these practical aspects of it would be what we would classify as network operations. For an example, we can think of an ISP or a cloud provider, and they would rely on a lot of these processes to keep their networks up and running. So again, the example of what happened with AWS a couple of weeks ago, or like some of the network outages that we discussed in the previous sort of classes, we could see like where things can go wrong with networks and where proper network management and operations is essential to, one, avoiding those things as much as possible, and two, to when things go wrong, to like trying to address that, fix that, and come back online again. So when we think about networks and network management, we can see when we particularly think about enterprise networks, the type of networks that we have discussed previously, these networks are complex systems with thousands of interacting software and hardware components. So in many ways, we can think of this as any other complex system like airplanes or power plants or any of these things, which has so many different moving parts, or like different hardware and software components in this case. And all of those things would require constant monitoring and control for those things to function properly. So this is true for any complex system, and that applies to the type of networks that we think here as well. So our goal here would be meeting the operational sort of standards that we aspire to, so like performance and quality standards that we set, and making sure those things are met and within the course that we define, because that is an important factor here as well. Cost becomes an important factor because many of the network management aspects, or not many, but some of the problems can be addressed by throwing more resources, sometimes, not always, but that doesn't always solve the problem in a more economical, effective way for an enterprise, because just because we have so many uplink connections so that in any case one fails, we have other, doesn't mean we are going to utilize all of them. Then we are paying for things that we are not utilizing, as an example. So again, like when we think of this as an overall picture, network management would be the process of coordinating between the hardware, the software, and the human operators in this sort of triangle. So how all of these things can work together, and what are the processes that we have for making those things work together. So that's essentially what we would think as network management. So with regards to network management, there is a standard model that we have, the ISO network management model, or the FCAPS model, so to speak. So in this, FCAP stands for Fault Configuration, Accounting, Performance, and Security. So essentially, this framework defines how an organization or an enterprise network should be organized in terms of the different management tasks or groups of management tasks that would come under each of these categories. So it essentially sort of provides a pre-existing or predefined standard framework for managing networks. So we don't need to go and invent a wheel about how do we go about managing a network that we have to manage. Rather, we can rely on an existing framework, and this is one of that. And each of these areas essentially focus on specific functions related to network management. So that those are these 5 functions. Again, we'll go into a bit more detail into each of these in a little later in the coming slides. But again, like for us, why we would use this framework is mainly because it provides us a structured approach, and it focuses on achieving the reliability, efficiency, and security sort of standards that we need to have in our network. So again, that's our goal, and this type of a framework will provide us that. So If we look into each of these components, fault management is about detecting and resolving any network faults that happen in our network, and doing that quickly so that we minimize any downtime. Say, for example, if a router has failed in our network, how quickly can we identify that, okay, that router has failed, and how can we restore that service, either replacing that router or rerouting the traffic around that router. So however we may do that, but fault management is mainly about identifying defects and resolving those issues to minimizing the downtime that we may get. Configuration management is about keeping track of device configurations that we have and maintaining them and preventing any sort of errors in them. So for example, if we have different devices in our network doing a similar function, we want to have the same sort of configurations across them. How do we maintain that across? Say, like if we update one of the devices, how does it replicate to all the other devices? An example again would be like, say, if we have a couple of firewalls running on sort of load balancing type of a setup, and if we make certain changes to firewall rules in one of those firewalls, how does that configuration now gets updated to the other failover firewall as well? So that's configuration management. Accounting management is about keeping track of resource utilization. So in this case, it could be about billing, it could be about capacity planning. Say, for example, in a large organization, we could manage bandwidth utilization by different departments, and then see like if a particular department is utilizing bandwidth more, and then we could see, is there a particular reason why that's happening? Is there an issue, or is it standard and that's what we expect? And in certain environments, this could also be used for financial aspects. So like if we are billing them for the services that we are providing with regards to the network, again, having this understanding of resource utilization can be an aspect of billing there as well. Performance management is ensuring optimal network performance. So this is like monitoring matrices like latency and throughput. And again, this is where we could like do this and identify any bottlenecks that we have, optimize resources, and again, like say, we could reroute things in an optimal way if that's what we identify. And it can also be useful for capacity planning. Say if we are all the time hitting sort of our capacity limits, that may indicate we may need some additional headroom capacity so that we can account to, like we can accommodate any sort of spikes that may happen in the network rather than sort of crippling our network environment. And finally, security management is essentially about protecting all the network assets from any sort of different threats. This is where we could use things like firewalls, intrusion detection systems, access control systems, and it's essentially the basic security principles is what we aspire to achieve here. Confidentiality, integrity, availability. So the basic security, how do we achieve that in our network? And that's what security management would do. So now, if we think about some scenarios around network management, as I said, one of the most common scenarios that we would come across where network management gets talked about would be when things go wrong, when something fails and we have a network outage. And that's where we would start to think about how do we manage this situation. So it could be a failure that's caused by hardware issues, like a hardware failure. It could be some software bugs. It could be power issues, like power outage or like some network, like power supply issues. And having proper management tools can help us identify some of these causes and restore the service quickly. So for example, if we have a hardware failure, then sometimes we may need to replace the hardware. But if it is a software bug or like a configuration issue, then that could be mitigated in a much a different way, in a much quicker way sometimes. Another scenario would be around security breaches. So this is again like in our network environment, we detect, or we should detect, if somebody who shouldn't be in our network environment has entered our network environment. So then how do we detect that? And then how do we contain any sort of unauthorized access or malware attacks that may happen as part of this? So again, security breaches becomes a critical place where network management would play a key role in one, detecting when things are happening or things are going wrong, and also trying to minimize the impact of such breaches. Because say, for example, if somebody gets into our network and then they try to move laterally in our network, how can we prevent that from happening? Say, for example, they compromised an end user device, and through that they got into our network. And if we can detect that early, we can either isolate that device from our network, or if they have started laterally traveling within our network, then how quickly we can detect the devices that are already affected and either cut them off from our network or isolate them into a separate pool in our network and safeguard everything else in our network. How do we do that? That would be part of sort of security management within our network management sort of practices. And another sort of scenario that we would come across a lot would be around performance degradation. And this can again happen for a couple of reasons. It can happen because of high traffic. So say if for some reason we are having high traffic to our network environment, it could be like some seasonal traffic that we are getting, or something has happened and people are more interested and they are getting into our network, or for some reason like our network has high traffic, and that sometimes can happen. It can also happen for like other reasons, like say if we have a couple of devices that are load balancing, and if one of those devices fails, now all the traffic is rerouted to one device, and now that's going to have much more than what it would normally handle. So that can reduce the performance. And it can also happen due to configuration errors. Again, if some configuration error has pushed all the traffic through a particular path, and now that path is going to be much more congested than otherwise how it could be. So with network management, how do we monitor these things? How do we monitor the performance of our network across the network? And then how can we and how quickly we can make corrective action so that the performance can be at a level that we are happy with. And then a couple of other sort of scenarios in addition to these sort of day-to-day issues. Again, network management would be involved in are around compliance audits, one. And when we say compliance audits, again, in sort of large enterprise network environments, there would be certain regulatory standards or regulatory compliance requirements for various reasons. Say, for example, it could be an ISO compliant. So like our organization is ISO certified, whatever ISO certification, or any other sort of industry certification, or sometimes it could be a regulatory governmental requirement if you are a government department or healthcare provider or things like that. So then we would need to do compliance audits, and this is where we would need to have detailed logs and reports that would be required by these compliance auditors. So network management processes would be the one that would collect these things, collect this information, and then provide those for compliance audits. And finally, one of the other sort of non-day-to-day sort of operation or regular operation or regular occurrence would be around network expansions. So particularly when we think about network planning and implementing sort of new infrastructure or expanding into new infrastructure, having an understanding of the network that we have and having all the understanding around performance and sort of performance bottlenecks and all these other factors can help us better plan for network expansions that we may need to do. So again, a lot of the network management tools and processes would be helpful in this aspect as well. So when we think about sort of different components that would be involved in network management, we would have a couple of things. So we would have the managed devices. So these are the routers, switches, servers, and all these sort of configurable components. And then we will have a managing server. So this is the one that is going to run the network management applications. And this is what the human operators would directly connect to or like directly interact with. And through that, they would configure and manage all these managed devices. And with that, we would also have all of these devices would also have data. In this case, it could be configuration, operational statistics, and logs, and so on. And so that would be part of all of these things as well. And to do all of these and to interconnect all of these things, we would use certain standard protocols for managing networks. So this is where SNMP or NetConf, such sort of standards protocols would come into play to communicate between managing servers and managed devices. And from a network operator point of view, how would we do such the management aspect? It could be, again, like few different ways. We could simply go through a command line interface, a CLI, and configure, like, say, PSSH into a router, make changes to that router. Easy, doable, but it can be a manual process, one, but also it could be very error prone. It could be error prone. So if you think about some of your past experiences with sort of even basic configurations of routers and switches through command line interfaces, it's not the prettiest or it's not the easiest thing to do. It is doable, but when you're doing like a number of these devices and need to replicate configurations or update configurations across a number of devices, it's fairly easy for that to be more error prone. So it's an approach, but it's not ideal. Then we have SNMP. So this is where we use structured monitoring and control using a standard protocol. So SNMP is the protocol, and MIB is the message that we send messages that are sent across. And here operators would like query and like set data on the devices. Then a more modern approach, and that would be more applicable for even for like automated and more sort of scalable configuration scenarios, is what we call netconf and the language Yang for that. This is again, as I said, it's more modern and it sort of mainly it's sort of more scalable for larger networks, and it's again another protocol. So if we look at SNMP in a bit more detail, so SNMP is a protocol for managing any devices on IP networks. So it could be routers, switches, firewalls, it could be any such devices. And it allows us for monitoring these devices, but also controlling such devices. And it supports like few different aspects of it. So like one, managing configurations on these devices, collecting information out of these devices around performance, security aspect of these devices. So it covers all these sort of different things that we may want to do with these devices. Again, examples are like a router or a switch or even servers for that matter. And with SNMP, it has sort of three key operations it supports. One is get, so that is retrieving variables, values from a device. So what is a setting? For example, a simpler way to looking at it is a setting that's already in the device for us to retrieve it and read it. So that's the get. Setting is the other way around. We are updating a variable on the device. Trap messages are essentially a way for us to have a sort of a connection, so to speak, whereby when something goes wrong with the device, like an event happening in the device, the network manager or the management server will be updated with this message or will be notified with this message. Say, for example, if a fault occurs in the device, this is where a trap message would be sent. And the MIB or the management information base is the virtual database of device information that SNMP uses. So, for example, with SNMP, we can say check the CPU usage of a router to see like if it is utilizing a lot more processing or it's okay. Or alternatively, we can say update certain firewall rules on a firewall. So like updating some configurations remotely. So with SNMP, we have few different components that make up the whole sort of SNMP ecosystem, so to speak. We have the SNMP manager or the NMS. So this is the central sort of control entity that's going to communicate with all the managed devices. So that is essentially sort of the network manager component. Then we have the managed devices. So these are the individual devices, such as a router or a switch, including it could be servers, desktops, so anything that can run SNMP capability. It has the SNMP capability that can be connected to the SNMP manager. And that capability comes from SNMP agent. So this is the one that would run on each of these managed devices. And that's the one that would collect information and store management data back onto those devices. So if we do a get, it will collect that information and send it across. Or if we do a set, it will get that configuration, update that configuration on that particular device. And then we will have to have certain communication capabilities. So that's where we would be able to communicate between the manager and the agents back and forth, either sending data or sending trap for events. Um, so, for example, an NMS could query a router for statistics on a particular interface. Say, for example, we have an uplink, or we have an uplink through, say, a fiber uplink and a mobile uplink in our router, and we could use the NMS could query the device and get that information out from the MIB from the device. So this is the two different sort of messaging modes that we have. So the standard request response mode is when the manager would sort of could request and the agent could respond. It could be either a set or a get operations. These are the ones that sort of the standard request response mode. And on the other hand, the trap mode is when the device can send unsolicited notifications to the manager when a certain thing happens on the device. So it can be set so that a router could send a trap message when its CPU usage hits a particular threshold. So say if its CPU usage hits a 90%, it could send a trap message so the network manager is aware that this particular router is in sort of high utilization. And particularly the trap messages are important, particularly for real-time alerts and sort of for, because like that's one of the ways when devices can quickly, because if we are going with sort of the request response mode, NMS has to frequently request to see what's the status of a particular device, say in this case, the router. Whereas if the router is able to send certain updates when it hits those events, it could be much quicker in terms of that information coming rather than the NMS polling to get that information back. But in saying that SNMP is not an ideal system, it has a number of limitations. It is simple and it's widely used, but for a number of different applications or number of different scenarios, it can have various sort of limitations. Some of these, maybe particularly for sort of modern networks or large networks, but nevertheless, there are certain limitations. The simplicity is, say, one of the defining factors of SNMP, but it also can be challenging when it comes to scalability. Because when we come to managing thousands of devices, it can become cumbersome. So when it's, if we take an example of a large ISP with thousands of routers, SNMP may not be an ideal manager to manage that. And with regards to sort of the polling way of getting updates from these devices, there is a high communication overhead because SNMP relies on that. And the more frequent polling we have, it can overload the network and the devices, in addition to the actual network traffic that's happening in the network. And one of the other information is particularly when we think about the trap messages, even when the device sends a trap message, it doesn't receive back a confirmation. So there's no proof of message received for trap messages. So say if a router has sort of failing and sending an alert to the network manager, and even then the router is not able to see whether it's received or not, and there's no way to know that. So that's another sort of key limitation here as well. And the modern protocols like netconf address some of these issues, particularly with event-driven mechanisms and more secure communications around this. So with regards to netconf, the main goal of netconf is it's designed to actively manage network-wide configurations. And some of the key features of netconf is it operates between managing servers and network devices. And it's again supports like retrieving, setting, modifying and activating configuration. So it still can do all those things that we would need to do when we think about managing a network. But it also allows atomic commits and also across multiple devices for consistency. And it uses the remote procedure call paradigm. So it's all XML encoded messages, and all the messages are sort of communicated through secure transport layers like over TLS, for example. So it's more ideal for large-scale deployments and when we need to do a lot of automation as well. So essentially, it sort of addresses many of the limitations of SNMP and also then provides a number of capabilities that are necessary for sort of modern large-scale networks, where a lot of those things could be automated and orchestrated and all that. So again, like within netconf, we have sort of similar set of operations to SNMP in terms of what we may want to do. So we can retrieve all parts of a device configuration. We can retrieve both configuration and operational state from devices. We can modify configurations. It also supports sort of rollback configurations if something has an error has been propagated. Say, for example, we push certain configurations to a router and that has sort of made things not do things that's not supposed to do. It's a missed configuration. So we can then roll back to its previous configuration. And it also supports a similar sort of thing to trap messages, whereby it can sort of create subscriptions. So then again, for receiving updates from managed devices. And along with netconf, we have YANG, which is the data modeling language that netconf uses. So it essentially sort of defines the data structure and syntax for the messages that is going to be sent between the managing controller and the managed device agent. The message format it's going to be sent is the netconf RPC, and it's formatted as YANG XML. And it essentially sets certain standards in terms of what are the correct ways that we need to encode this information, and it sort of ensures consistency and sort of correctness in all the messages that are sent across. So now, if we think about network management from an operational point of view, there are again number of things that we would do with this. So as we again like previously mentioned, it can help us with resource planning. So that is to allocating bandwidth and hardware for certain applications or certain areas of our enterprise. Uh, it can be part of our monitoring and security operations. So this is where we could use different tools to detecting anomalies. It could be sort of AI, ML tools or any other tools that can detect anomalies. Um, we can use it. We can do troubleshooting and optimization. So again, when we have a centralized control, we would be able to control all the different parts of our network and troubleshoot any part of the network rather than sort of relying on individually looking at each of these devices. We now have a central place where we can do these things. And also, with a lot of the modern networks and modern sort of ways of managing networks that we have, a lot of these things could be automated as well. A lot of the repetitive tasks could be automated. Network configuration management, so sort of upgrading configurations can be automated. Um, Things like firmware upgrades can be rolled out across, say, hundreds of routers through an automated process rather than individually doing it on a per device basis, which could be cumbersome and sometimes impossible. So these are some of the things like, again, this sort of centralized network management could enable us to do. So now from network management, if we now sort of set our focus on network operations, this is where we talk about the day-to-day tasks like monitoring, troubleshooting, performance managing. All these things would be part of network operations. This is where a network operations center that's running 24/7 and looking at all these aspects of a network would come into play. We will look at NOx in a bit more detail in next week's lesson, but network operation centers are crucial for many industries, particularly when reliability and sort of consistent overall connectivity is important. So telecommunications, financial institutions, energy sort of providers, governments, or any sort of large enterprise where connectivity and reliability of the connectivity is important. Network Operations Center would be part of that overall picture. So again, as I said, we will go into a bit more detail of NOx in next week's lesson, but that's essentially where a lot of these day-to-day operations would happen. So if we look at few of the different activities that can happen in a network operations environment. So this is where analyzing and responding to any sort of events and incidents. Um, um, and it could be like communicating with third parties and technicians when things go wrong and sort of tracking and resolving those issues. It could also involve some of the sort of mundane IT tasks, like data backups, and sort of providing antivirus and firewall supports where like certain things may be blocked by a firewall. So then do we add exemptions or can we add exemptions? Sometimes certain part of the business may need to be allowed to access certain things and other part of the business shouldn't be able to access certain things. So then how do we add those limitations? So all of these things could be part of sort of network operations. So by having this sort of centralized network operations, we can get a number of benefits to enterprise environment. First one is proactive monitoring. So we can look for potential issues in a network and detect them early and escalate them before they become a much larger problem. Uh, we can enhance performance again by optimizing updates and proper maintenance of our network. Again, overall network performance could be improved. Similarly, reliability and redundancy could be improved as well because we can minimize a lot of downtime. We can improve security. So then all of these things can contribute to sort of improved reliability and redundancy. Um, Again, having this sort of, again, centralized operation, network operation, it can also be much quicker when things go wrong because we can quickly troubleshoot, more efficiently troubleshoot, and also we can resolve issues much faster because that particular part of our organization or that network operation center would be particularly specifically dealing with these things. And when we have sort of scalability or like scaling up needs for an enterprise, again, having this sort of centralized operation would be crucial and beneficial in that scenario as well. So with regards to this, again, like some of the things that we would do in this sort of a centralized network operations, we would have continuous monitoring of the whole network. So having a full picture and continuous monitoring of that full picture of all the network appliances, all the devices, connected devices, and anything that's important to us in that network, so that we can track and identify issues early and prevent sort of outages or minimize sort of any downtime in our overall network. We should be able to prioritize incident response. So when things go wrong, we should be able to detect them quickly and then resolve them, and also keeping any sort of important people updated about those things as well. Say, for example, if a particular connectivity to a particular server is down, we should be able to, the network operation should also inform the part of the business that's relevant to that so that they are aware of this thing happening. So any sort of impact from that could be managed by that end as well. And we would also, in a standard large enterprise environment, we would also use what is called a tiered organization for network operations. So this is where we could have, like, say, level 1, level 2, level 3, or like tier 1, tier 2, tier 3 uh, um, network operations personal staff, and they could be assigned incidents and tasks based on their severity and the expertise of those teams. So, like, say, for example, a level 1 could handle any of the basic issues that come about, and a level 3 can handle more complex problems and troubleshooting and things like that. So that's again something that we would do in a large scale enterprise network operations. Then in all of these things, having a proper understanding of what's happening from a data point of view is important as well. So that's where we need to keep track of all the different operational matrices. So this is where we monitor all the sort of performance indicators like uptime, latency, and all these things. And then we can look at these things in a sort of a historical way and see when things are being impacted, when sort of the uptime, do we have a pattern of uptime issues, or do we have a pattern around where latency goes down or latency goes up, um, that type of thing. And for most network operations, people become important, people with specific skills become important. But then also in sort of large scale enterprises, having standardized processes for all the different scenarios is important as well. Because, like, say, when we say take a large NOC, for example, network operations, for example, it could have hundreds of different technicians working in that. And all these technicians and engineers and all of those people, they could do things differently if they are let to do on their own. So that's where having standard procedures so that we have consistency across the responses we have is important. And similar to any sort of security operations, like in network operations, also we need to have business continuity plans. So, for example, if we have a large outage of some part of the network, what is our plan? Say, for example, a good example, a recent example again, going back to the AWS outage. If and when something like that happens, what is the contingency our organization has for business continuity? Because, like, that part of the network, that also means certain services are no longer reachable. Then are we able to continue our business even in that scenario? Do we have the capability, the capacity, or the alternatives? If not, why? So those are some of the things, again, are good to think about when it comes to network operations. So with that, we can also sort of start to think about where network operations is going with sort of the newer trends. We are seeing a lot of automation and orchestration happening in a lot of network operations environments. We are also seeing a lot of outsourcing within network operations. This is where we come across managed NOC services. So these are outsourced third-party services who would provide the network operation service for your enterprise. So your enterprise will still have your own network and all that, but this third-party service will provide the 24/7 monitoring and all the staffing for that network operations center, and they will identify incidents and escalate incidents. And it could be sometimes a shared responsibility arrangement. Say, for example, they would do the 24/7 monitoring, maybe they will manage all the level 1 incidents, and level 3 type of level 2, 3 could be sometimes escalate into the organization, internal staff, or they could respond overnight, and daytime it could be the internal staff. So it could be that type of hybrid approach as well. And as with anything these days, but I mean, AI and ML is becoming a big part of network operations. But in saying that, network operations always had different aspects of machine learning for a number of years, like for decades. We had like a lot of anomaly detections, and all these things used different ML components for many, many years. So it's not a new thing with AI. It's not a recent thing with all this AI bubble and all that. ML has always been a machine learning, and all those things has always been a part of network operations, and it still continues to be. But there are new sort of avenues also coming about, like sort of using AI around identifying link congestions or like impacts of that to different users, or simulations and all that. So there are different things that can happen as well, or that can be done with these as well. And with regards to what are some of the things that you could think about sort of learning or knowing to some extent, because again, like as a sort of network technology person, uh, a NOC or network operations could be one of the entry level positions or places where you may end up in, and where a lot of these network operations and network management tools would come into play. So having an understanding of these different technologies and tools would be beneficial. So again, like some of the things like SDNs and all these ideas and things, things that you may be familiar with. Um, and there are other sort of specific tools or protocols or technologies. Some of these things are good to have an understanding and knowledge of. So again, this is just as a, sort of a reminder of explore a bit more beyond what's covered in these courses. Um, from that, if we sort of go a bit further, thinking about some of the newer and emerging areas, again, we sort of so far we looked mainly around network management as sort of general enterprise networks. But a lot of these things would also involve sort of cloud networks in the type of networks we have, either hybrid or purely cloud networks and so on. So this is where we would rely on a lot of cloud native tools for monitoring and control. And this is where we would, the networks we manage could be virtual networks and VPCs and SD-WANs. We could also need to think about multi-cloud environments, and how do we interconnect between multi-cloud environments, and what are the sort of technologies and solutions that we can use to interconnect and manage across these multi-cloud environments. And there are a number of sort of different tools a lot of these cloud providers or like have, like the AWS CloudWatch or Azure Network Watcher, that provides sort of visibility into our virtual networks. So an example would be like, say, if we are an enterprise where we are using AWS and Azure for different parts of our organization, then we need to have consistent firewall policies across both of these cloud environments. So these are some of the newer challenges that we would have with cloud-based network management. So as we said, like AI and machine learning is becoming again more taking few. We are utilizing them in few different ways. in network operations. So a lot of the predictive analysis and for sort of proactive maintenance. So we can look into before if we can predict before things go wrong, like identify some of those things. We can use AI essentially for any anomaly detection. So that's one of the classical use case. And one of the newer sort of areas where it may be gaining traction is around self-healing networks. So when issues are identified in the network, if those issues may be resolved by AI tools, it could be resolved, but proof solution, sometimes it can mess up things. So like we need to have certain guardrails around these technologies and adapting these technologies, but that's a potential as well. So like large providers, like say, for example, Google may use AI to optimize the overall network of their data centers and things like that. So there are a lot of places where it could have different applications and use cases. Another area where sort of network management operations is going is around automation and orchestration. So this is where we reduce a lot of the manual tasks, and a lot of these things are automated. And when we say orchestration, it's sort of coordinating all of these automated tasks across sort of large number of devices and services. This is where we use tools like Ansible and things like that. And so, for example, an example would be automating firewall rule updates across hundreds of sort of branch networks using Ansible, so things like that. And one of the other sort of newer, like a trend that's coming about is called network as a service. So it's essentially a subscription-based networking capability. So it sort of avoids a lot of upfront cost for enterprises, but then it also has ongoing costs. So this is a balance between those. And sort of similar to any sort of as a service thing. And an example is like Cisco provides a network as a service offering where it can offer you to sort of deploy SD-WANs without the need to having specific hardware and so on. So it can be beneficial for certain businesses, and the business model needs to fit to that, but it's an emerging approach as well. And one of the other sort of related sort of development is around sort of sustainable network operations, because sustainability in IT is a bigger challenge because a lot of the larger networks and larger resource hungry ways of doing things has become a big challenge for sustainability, energy usage, water usage, and so on. So then how do we go about thinking about more energy efficient hardware, or like thinking about what's the more power efficient or power aware routing approach, thinking about sort of carbon footprint of different things. So this is where we start thinking about data centers and how we can optimize data usage and of overall network and all that. And how do we reduce all those things? So again, network operations plays a big part in this as well. So that's essentially the key topics that we would discuss today.